Hello everyone, my name is Gaurav and my topic of discussion is electrostatic potential. So before I actually start electrostatic potential, I will first explain you what is electrostatic potential energy, because electrostatic potential energy can be explained only in terms of electrostatic potential energy. And electrostatic potential basically is a form of potential. Any form of energy is evaluated in terms of work done. And in case of potential energy, we evaluate it in terms of some external work. First, we understand to define potential energy, we have to define a conservative field. Like, what is the conservative field or conservative force we might call in terms of force? Conservative force is that force whose work done only depends on its initial position and final position and not the actual path taken. And in a round trip, the work done becomes zero. We have a very analogous example to electrostatic potentiality, which is gravitational potentiality. And it would be easier to understand electrostatic potentiality if we understand gravitational potentiality. So what happens in case of gravitational potentiality? Suppose we have an object placed on Earth, right? So a force mg, which is gravitational force, is acting downwards. Now we define potential energy in terms of an external force, which is exactly equal to mg, and we will evaluate the work done of this external force, which is exactly equal to gravitational force, but whose direction is opposite to the gravitational force. Now we give a slight impulse so that the block would move with uniform velocity, because net acceleration is zero, so it will keep on moving with uniform velocity. So let's say if it displaces through a distance h, so work done of this force would be F external into h. As F external and the displacement in the same direction, so we can simply write F external into h. Now this F external is mg and this is equal to h. Now this external work done is basically stored in terms of potential energy. We say that the potential energy of the block and earth system has changed by this much amount. We can define potential energy only for a system, but not for an individual particle or object. So here, the system involved in the calculation of gravitational potential energy is block and the earth. So by doing external force, we have actually changed the position of an object, and because of that, a change in potential energy has created. So this mg basically is change in gravitational potential energy. This is basically gravitational potential energy. Change in gravitational energy. So this is an indirect way to measure potential energy by doing some external work. Now we come to our actual topic, which was electrostatic potential. Now we will understand what is electrostatic potential energy, right? So in the same fashion, we are going to do some external force. We are going to do some external work done, and because of that external work done will be stored as electrostatic potential, right? So what would happen in case of electrostatic potential? Let's see. So like in case of gravitational potentiality, we had gravitational field. In case of electrostatic potential, we'll be having electrostatic field. So there would be a charge which will basically create an electric field around itself, like this. Right? Now, let's say there is another charge which we call that test charge. Now, this test charge is placed very far away from this charge, which is basically creating field. Now, we will move this charge at this position. We can assume that the effect of this charge, or we may say that the field of this charge at this point would be 0. But the moment we start moving towards this charge, now we have to calculate electrostatic potential. So the moment we move towards this charge, it will have to oppose the electrostatic force between these two charges, because we have assumed this charge to be positive. So as we move closer, it will repel this charge. So there will be, why would it repel this charge? Because there would be electrostatic repulsion between these two light charges. And so we have to do some external work done, right? And this external work done basically will be stored as electrostatic potentiality. So we have to do that work done. So we select the force in such a way which is exactly equal to electrostatic force. So if we take, let's say, a point P in this electrostatic field from a distance r from this charge plus q from this charge. So at this point, if we talk about it, we are moving towards the field, right? So we have to do some external force. We have to apply some external force so that we could move towards this charge. Now we will select in such a way that this external force will exactly equal to the electrostatic force between these two particles. So these two particles will be repelling each other at this point, and we are applying some external force. We are constantly applying this external force from this position to this position. Obviously, this force will be variable as the distance will keep on varying as we moving towards the charge. So the distance will keep on moving. So this force will be variable. But we have selected this external force in such a way which is equal to the force due to electrostatic force. So now we can say that work done by this external force would be equal to integral of F external dot dr, and as we are moving from infinity to certain point in this electrostatic field, so we write it from infinity to some point P, right? So we are moving from infinity towards point P, towards the electrostatic field of this charge. So obviously we have to do some external force. We have to apply some external force to move it towards this charge. So there will be some work done, and which can be calculated F external dot dr, which is the standard definition of any work done. Now, what would happen? This external force is chosen in such a way that it is exactly opposite to electrostatic force Fe, and we are slowly moving this object such that there is no acceleration. Only then these two forces can equalize each other, right? So this thing also we have to keep in mind, that we will be moving gradually, slowly, so that there is no acceleration while we are moving from infinity towards this point P, right? So this external work done will be stored as electrostatic potential energy. Now, we can also write this external force W external is equal to minus of F electrostatic dot dr, right? Because our electrostatic force, this was anti-parallel to F external. So this can be written like this. Now, this electrostatic force can be written as K QQ by R square. K QQ by R square. Now, the direction of, as we do, now we are calculating in terms of electric force. So, electric force is acting in this direction. So, this electric force will be in this direction, and dr is also in this direction. So, this is dr, because this electric force and dr is parallel to each other. So we can simply write down this dot product as Fe into dr, and Fe would be KQQ by R square into dr, where K is Coulomb's constant, as we know this. So KQQ, now this is infinity, we are moving infinity to some point R. So this comes to be KQQ dr by R square from infinity to R. Now this comes to be, when we evaluate it, this comes to be minus KQQ, and this is minus 1 by R after integrating it infinity to R. This comes to be KQQ by R. So this is basically electrostatic potential energy, right? This is basically electrostatic potential energy. So electrostatic potential energy can be evaluated in terms of charge field system. In this, there would be two players. First, a charge which would be creating the field, electrostatic field around it, and the other is the test charge which is moving towards it. Now, because of these two, this charge and field system, electrostatic potential will be created. But there is one property which is only the property of a field, and that is electrostatic potential. So if we divide this external force, by test charge, which was actually moving towards the charge which was creating the field, so this becomes potential at that point, which is known as electrostatic potential. So now we are in a position to define electrostatic potential. We can define it that this is work done per unit charge while we move from infinity, from a very large distance, to some point inside in a field, in the electrostatic field. So potential at point P can be defined as electrostatic potential negative of this was W external that we did from infinity to point P divided by test charge Q. So this comes to be in terms of electrostatic field Q E dot dr. This was the field. This E is created by the charge Q, and this EQ is basically AQQ by R square, right? So So this Q, so finally this can be written like this, E dot dr, and integration will vary from infinity to. So this is definition, this is how we can define electrostatic potential. So what we did actually, we did the same thing. We applied the external force, which was exactly equal to electrostatic force. Then we evaluate the work done of this external force, and this work done per unit charge was basically potential at that point in the electrostatic field. Obviously, because we were moving from infinity to point P, so at infinity we can assume potential to be zero, because electrostatic field can assume to be zero at a very far away distance. So there at infinity we can assume potential to be zero. So potential at any point in the electrostatic field where it has some sort of influence, at that point potential would be given by the sequence equation. Vp is equal to minus E dot d. Similarly, we can calculate potential difference also between 2 points.